what is x to the 1/2 power? Well, you can't know unless you define what you mean by a fractional exponent, but we also have to discuss why we define fractional exponents in any particular way. Well, when mathematicians define things, they want to keep it within the limits already created by our previous definitions. So our guy says, oh, I wish the formulas would still work. All the formulas we developed about dealing with exponents, I wish they still worked even if I had a fractional exponent. And then I could define rules such that those formulas still worked. And then he notices, if you multiply x to the 1/2 by itself, you get x. And this is suspiciously like the square root of x times itself to get x. And then he comes to the conclusion that x to the 1/2 is basically functions the same way as the square root of x. And then maybe he takes another case in which x is raised to the 1/3 power. And then he notices that that functions exactly the same way as the cube root of x. And so then he decides to make his definition. So x to the 1/n power is equal to the nth root of x. And as we see from these examples, using the rules of exponentiation, is particularly when you multiply them, you add the exponents, x to the 1/n functions exactly the same way as the nth root of x. Now this deals with situations in which there's a 1 in the numerator, but it could just as easily refer to situations where there's a different number. And so here's our definition again, and here are the consequences of that definition. Because we know that a power raised to a power will just multiply the exponents. So in this case, m over n is equal to 1/n times m. So x to the m over n is equal to x to the 1/n, that whole thing, to the m power. And that allows us to find what that's equal to. So that's equal to the nth root of x to the m. So from our intuition, we get a definition, and from the definition, using the rules we already defined, we can find out the consequences of it. So for any rational number, any fraction m over n, we're able to find what that means when it's an exponent.